Okay, we're going to look at the tangent reasons that are pretty darn important as well in circle geometry. Let's look at the first reason. When you have a straight line that just touches a circle in one point, we call that line a tangent line. And it turns out that if you have, at the point that it touches, if you have a line that goes to the center, well, that'd be the radius. It turns out that the tangent is always perpendicular to the radius. So if you've got a tangent line to a point, and that point is connected to the radius, it's got to be 90 degrees or perpendicular, and that's a pretty useful reason to use. And you can write tangent perpendicular to the radius. You use it all the time. Here's another one that gets used a fair bit. If you have two tangents that touch at a point, say A here, one tangent goes this way, another tangent hits a point right here, it turns out that if you have two tangents that go to the same point, the distance from B to A will equal the distance from C to A. So we can say tangents from the same point are the same length from the point B to A and C to A. Tangents from the same point create two equal line segments. Two tangents drawn to a circle from the same point outside the circle are equal in length. Oh, there it is set. Okay, and then there's the famous one that's probably used more than anything else, or at least I've seen it, feels like it is. It's called the tan-chord theorem. And here's how it works. If you've got a tangent and then it touches at a point, and you draw a triangle inside the circle, so that a triangle that's circumscribed, that passes through the 3 points, well, this is what happens. There is an angle between the tangent and the chord created right here. Here's the chord AD, and there's another angle over on this side. We'll call it D1 here, between the chord BD and this D1. Well, on both sides, let's just take a look at it. This angle D2 here, right here, it equals the angle B. The angle between the tangent and the chord equals the angle in the alternate segment. So if you've got an angle right here in between this tangent and the chord, it'll equal the angle at the top of the triangle here in the alternate segment. And this angle over here, D1, it's going to equal angle A. This angle between the tangent and the chord equals the same angle as the angle that opens up to that same chord. Or right here, the angle between a tangent to a circle and a chord drawn from a point of contact is equal to the angle in the alternate segment into that angle that opens up, that subtends the same chord. That angle equals that angle. Make sure you get that right, because it's real important. Okay, we're going to do some exercises where we've got to use this. And it's not so hard, because here you go. That's a radius, and this is a tangent. And a tangent is perpendicular to a radius. So that means this angle B1 isn't known. Down here, another tangent perpendicular to a radius. Hey, there's quite a few things here. So that's what you use here to get going with these questions. If you know one angle, you know the angle sum in a triangle equal 180 degrees, so you can create an equation there to figure it out. Same sort of story here, but watch for this. See that OC and OB? They're two radii. They're the same length. So that means these two angles are the same, B1 and C, so you can use that in there. And then just play around with it, because you know the angles. This is a tangent, so tangent perpendicular to a radius. This angle here, this angle B1, that looks like the angle between a tangent and a chord. So, there's an angle up here that it has to equal. See this angle D here, CDB? That angle up there in the top of the triangle has to equal this angle in between the tangent and the chord. Hey, and they have parallel lines here, so that X and that D1 are called alternate angles, and they're equal because CB is parallel to DE. So, and these are both tangents. They're both tangents. Well, tangents from the same point are equal. So, okay, you can use a bunch of ideas in there. Well, here we have a big triangle here, out here like this. We're told that BT is a tangent and DT is a tangent. DT and BT are tangents. Well, tangents from the same point, we can get started there, figuring out these angles. And maybe if we're careful, we're going to be able to get some other stuff too. If we can get these angles, then maybe we can play with some other angles. Anyways, you can try and figure out X, but it might be a little tricky. It's a bit of a puzzle, an investigation. So I'm not doing all these questions. I'm just giving you hints on how to do them. And I'll send out the memo and you'll be able to do them then. So I hope that helps.